Okay, great. Well, thanks for having me here. It's really great to be here. Figure we'll just jump right into it. I'm BJ. And if at any point you have questions about things, feel free to just maybe you get let me know. This is your workshop, so I want it to be what you want it to be. I have sort of my own agenda of what we're going to go with, but I'm perfectly fine with detouring from that. Okay, if there are questions that are related, hopefully. So, Max MSP, who has used Max before? Okay, higher level or medium, or just kind of getting used to it, or?
I did it 10 years ago.
Okay, all right, fair enough, yeah. A lot has changed since then, so we'll get into it. Obviously, you should get Max now. It's 1974. It will run for 30 days without bugging you to register it. Otherwise, and after that, it won't work anymore. It's not crippled while it's in the demo mode. And I think the cheapest license is the student one for $60. You can get it for a year, and then if you decide that you want to keep it, then all you need is about EDU email address to get that discount. And after that, you can actually credit that $60 toward the full purchase. I think it's $250, something like that. It has three major components: Max, MSP, and Jitter. Max handles numbers and number-based things, MIDI types of functions and whatnot. MSP is signal processing, collection of data and objects inside the program. And Jitter handles visual processing and matrices and all that stuff. Okay? Also, if you haven't done so, get the SDK from Amir.net. So you want to just go to Firefox or wherever, go to Amir.net. You can either log in with your Facebook or whatever. I'll run with me. And there's a link here for Amir SDK. So at some point, download that, or whether you download Max 5 or 6, download that and install that, and then just give Max a restart after you install that. All right. So Max is a programming language. This programming language, unlike other programming languages, is more graphical based, and the idea is that all the programming that you're doing sort of has this data flow type of idea in mind. So we're used to working with data flow in this type of paradigm. If you're going to record something on your computer, you start with a microphone. That's one entity right there where the sound comes from. Then it goes to your sound card. It comes through a USB cable or through an XLR cable. And the sound card goes to your computer, some FireWire, USB, something like that. And then you do whatever you do with it on your computer, and that goes out to your speakers. And it's the same basic type of thing that happens inside Max. Each of these different components that's in here has a very specific function, and they're connected to each other, and they throw information around in a certain way. In Max, some of the terminology that we use is we would refer to all of these four components as objects. Each object would have a certain function, and the connection between them would be made with what they call patch cords. Okay, so instead of saying differentiating between an XLR cable or a USB cable or FireWire cable, all the connections are made through what they call patch cords, and that's how data is flowing from one object to another. The actual sessions themselves inside of Max are called patches, okay, or patchers. Okay, so that's the crash course in that. Let's get looking at Max. So go ahead and fire it up. I have Max 6 here. Max 6 and Max 5 are very, very similar in most regards. So if you got Max 5, don't sweat it. It's totally fine. It's backwards compatible. Basically the same thing. They made some advancements in Max 6 that we won't even come close to addressing here. The most noticeable one is curvy patch cords. So you might notice a little bit of difference there if you're looking at Max 5. Okay? So when you start up Max, you may get a splash You may not. I disable that. What you will get is this sort of floating menu back here. We'll talk about what that is in just a bit. Right now, let's just go to File and New Patcher, and we will start with a blank patcher like this. That is a blank canvas here. Now, a patcher is, like I said, a blank canvas by which you put on these objects in here. Unlike Finale or Sibelius or Logic or Pro Tools, when you start Max, there's no little paperclip that comes out and says to you, hey, it looks like you're writing a program. What would you like to write this program about? And it's completely in your domain to do whatever you want. And so that is a good thing and also a bad thing. The good thing is that you have freedom to do whatever you want, and it could be anything. It could be some sort of patch that helps you compose in some way, helps you do some sort of analysis of modes or harmonic events, or something that turns on the lights in your house, or I mean, it could really be anything. And that's a type of flexibility that you have inside of Max you don't have in other programs. If you were to use this MIDI keyboard to, I don't know, trigger sound files of Samuel L. Jackson quotes or something like that, like Logic would be like, hey, what are you doing? That's ridiculous. Why would you ever want to do that? But you can totally do that in Max with total flexibility. Somebody was telling me that a program that they saw that it was linked up to, it was a Max patch, and it was linked up to a Facebook page. And whenever you light, it was for a plant, and whenever you light this plant, it watered the plant. So you can do that. Of course, the plant died. You can't water the plant, freaking died. But but you can do it. Theoretically, you can do it. I am inside of Max every single day. I write programs in Max for every little day, everyday functions. It's so useful to have these types of skills on your belt. The more you do it, the better you get at it. It's a full-blown language that you can write whatever. And in fact, if you're looking to develop certain apps for it, you can write once, and then you can compile it to Windows format. You can even get these things in the Mac App Store if you wanted to. So, how does the programming actually function? Well, we have to call up certain objects in order to make things work. Now, this might seem really complicated because it involves that you learn a whole lot about the language, but not so much. For example, pretend that I am an object, and I'm an object called number, and my whole job in life and in Max is to just visually display numbers. That's all I do. The user puts some number in me, and then all I do is display it on the screen. Fine, fair enough. So then data flows from me to James, and maybe he is a plus object. Okay, so all he does is receive numbers and then add some other number to them. Okay, and the user might specify some number by which to add as what they call an argument. So suppose you're the plus object, and then you have an argument of 3, and so the user types in me 7, and then I'm connected to you, and so some calculation happens when those two numbers go to each other, and then but we can't see that until that's connected to another object like me that displays that number. So for example, you don't have to actually do this right now, but the basic gist of it would be if I had a number like that, and then I were to have plus 3, so an object called plus and then 3, and then I had another object like this, number, then when this thing all happened all together, I'm actually interacting with it right now. And then 7 plus 3 equals 10. And then, of course, you can string in other objects like minus. So maybe minus 2 would take place here. And that calculation happens. And then another number to display that. And then the user is interacting with this. And 8 plus 3 is 11, minus 2 is 9. Right? And so interaction actually happens in this sort of data flow language inside of Max. It's very immediate and it's very interactive in that regard. And the more you learn about the language, the more objects you learn in the language, the more verbose your programs can be. So let's get on with that and erase these things. The basic data structure inside of Max is an object called button. To create a new object, you press the letter N, like that, and then you can type in the name of an object if you know what it is. So we're going to type in one called button, like that, okay? And button actually turns into this type of user interface object, like that one little comment in here called button, so you know that's what that is. And the button is so common that you can just press the letter B, actually, to get that. So let's create a couple buttons here. So just, again, just pressing B. If you prefer, you can press N or new object, right? And that, once again, will bring up this sort of window here by which you can type in button and stuff correctly. Button, like that. So I have a whole bunch of buttons here, looking good. Okay? Now, each of these buttons has in itself an outlet over here and an inlet on top of it. Data flows from outlets to inlets through patch cords. Patch cords are little cables that connect like this. Okay? And it's very easy to do. You just click on the outlet of an object and connect it to the inlet of another object. Like that. So let's make a little like button tree. Something like this. Do it however you want. Cool. Sound good? Yeah. So this mode that we're in right now, we're actually programming, believe it or not. We're calling objects to interact with other objects in a certain way. It's kind of like Mousetrap. If you ever play that game, remember you can kick the boot into the marble and it's the thing, and eventually kill the mouse. So we're killing mice and Max right now. Now, we've been patching right here. In order to turn this thing to a fully functional program that we can then sell to whoever is going to pay for it, you click on this little lock in the bottom left-hand corner. Or you show it again, I'm sorry. Oh, sure. It's the bottom left-hand corner right here, which of course is being locked. There's a little lock icon. We'll see it. Or you can use the key command, Command E, which is incidentally the same key command we use to switch views and Fidelity. One fact, and now you know, if that helps you remember it. So Command E to lock and unlock. When the patch is locked, you can't any longer make new objects. Okay? So, but the program functions. So in other words, if I click on this button, like this, I can see that data is flowing from one of these objects to another. Oh, right? This event that's happening here is called a bang. Okay?
Is that a type of event or are all events called bangs?
This is a type of event, but for the most part, anything that button will only send a bang. That is the main event. So, we have, I'm going to unlock the patch now. Again, you can click the lock at the bottom left-hand corner. When you press Command D, unlock it. And I'm just curious if you can tell me why this might be a bad idea. I should say, what would happen if I did this? Anyone?
Feedback.
Yeah, exactly. Right. So essentially what would happen is I would click here and it would send the bang to here, to here, to here, to here, to here, and it would never ever stop, and the computer would crash in what's called a Stack Overflow. So you don't want that to ever happen. Okay? It's going to happen. It's inevitable. So just know that when it happens, life will go on and we will be okay. Okay? So for the moment, I'm going to get rid of that, and I'm going to save this as my button tree desktop. Everyone good so far? Okay, cool. Let's move on to something more interesting. So close that. Let's do File, New Patcher. And let's talk about notes and computers and stuff like that. Is anyone not familiar with MIDI? The term MIDI? Okay, all right, that's it. 5 minutes. That's good. Thank you. Thank you for knowing what that is. The basic way of getting MIDI data into your computer is with a number of objects. One is called MIDI in. Another one is called note in, which is basically a subset of MIDI in. Instead of it having all MIDI data present, it has only notes, pitches, velocity, and MIDI channel come through. So I'm going to get rid of that for the moment. Now you don't actually need a MIDI keyboard hooked up for this little part. I just want to give you sort of a demonstration of how this might be. In my computer right now, I have connected this Core Nano key here. Okay, so this is technically sending MIDI data right now to Max. Max is receiving it through this node in object right here. Conceivably. And so the student might drop this yesterday, so I'm not even sure if it works actually. It may. But I have no way of displaying the data coming out of node in. I need some number objects in order to do that. So let's create a new object, and this object will be called number. And the number object does just that. It literally just displays numbers. So it's a new object called number. In fact, it's such a popular object that it also has its own keyboard shortcut, I. You just press I to get one. I as in integer, get it? As opposed to like a floating point number, which would be a decimal point number. There are also ways to get that too. So I'm going to create 3 number boxes here.
What were you doing just now? Pace or something like that? How did you get the number box?
Oh, I just pressed I. Yeah. Yeah, just the letter I on my keyboard and to make lots of numbers. Just in the same way that you can press B a whole lot and make lots of buttons. Just one of those shortcuts. Because it's incredibly popular common to do numbers inside of here. Okay?
Does that red dot, that red triangle, does that help you understand that
I'm so glad you mentioned that.
that it worked or something?
What happens is when you put your mouse over an outlet, I'm not sure how well you can see it, it actually says what type of data is coming out of that outlet. So for example, the first outlet of node in gives you pitch. Okay, so it's going to be a pitch value, a MIDI pitch value. So 60 would be middle C, right? 62 would be D above middle C. The middle one gives you velocity, and the third one gives you MIDI channel. Okay, so each of those numbers, when I press the key, is going to be displayed here. Okay, so if I'm pressing middle C, and I'm really hitting it, so it's middle C with a velocity of 119. When I take my finger off the note, it's middle C with a velocity of 0. It's a note off message, right? So, all these things. And of course, it's transmitting data on MIDI channel 1, right? So for each of these things, it's just displaying notes. You can't do this right now if you don't have the MIDI keyboard set up to get the basic gist of how it works. Now, the question is, well, why can't I hear any of these things, right? Why can't I hear it? It's broken. What is the problem? So this is what differentiates Max from other programs. Max has no idea that you want to be able to hear things you're playing out of here because you haven't told it so. So people kind of freak out and get angry at Max for that reason, but it just doesn't know, okay? So we love it anyway. So how do we tell it to communicate then with our computer's synthesis engine? You have to use some way of getting these notes back out to QuickTime, or if you're on Windows, the Microsoft synthesizer. And that would be an object called, anyone want to guess?
Node out.
Yeah, node out, yeah, exactly. And if we were using MIDI in, we can use MIDI out, exactly. So if you hold your mouse over note out, the first inlet accepts pitch, and look at that, there's a pitch value, boom. Middle one connects velocity, and here outputs that value. This one outputs MIDI channel, right? And then when I'm playing notes, right, you get the idea. Cool. So that's basic note in, note out stuff inside of Max.
You said it's sending the MIDI data to QuickTime?
Yeah, the reason is because this needs to, the MIDI data is just numbers, obviously, right? So it needs to be synthesized somehow. On a map, it synthesizes that data with using QuickTime synthesis engine. There's a way that you can get this stuff that if you want, in fact, if you lock the patch and double click it, you can see that you can send data from max 1, from Max or from Max 2, and you can then route that into Contact or GarageBand, whatever you need. And there are also ways to get it so you can load up VST synths like right into the thing too, which I'll show you in the toolkit. In that Ear SDK thing, it's got a whole lot of that stuff in there. But that's the basic gist of that stuff right there. Okay. All right. So let's talk about this then. Since you might not have a MIDI keyboard necessarily set up, let's talk about ways to make notes just with the computer. I'm not necessarily needing another type of interface at the moment. We definitely want to have this note out thing, right? That'll communicate with our sound card. And the deal is this: if I were to connect a number right here, it would send a pitch value to note out. It's sending 60 to note out, except it's currently not paired with a velocity message. So it has no idea how loud to play this thing. Okay, so these things have to be played in pairs. In order for that to happen, it's easiest for us to use an object called MakeNote, like this, where you supply a default velocity value, like say 100, and then you supply how long the note is going to last. For example, like half a second, 500 milliseconds. Okay? So, I know this might seem a little bit heady, so just go with it for a second. The MakeNote object here receives some number in its first inlet. It then treats that number as the pitch in a MIDI message. It pairs it with this message, which will represent its velocity, and then after this amount of time, in milliseconds, it will send a note off message. So altogether it looks like this. MIDI note 60, after half a second, 0. Some other notes, after half a second, 0. So they all get 0. MIDI pitches, by the way, in case you're not familiar, go with 0 through 127 to represent everything from pitch, velocity, timbre, pitch bend, all these types of things. Those are MIDI values. Just as a refresher. So, if I connect my velocity there, pitch here, pitch output, pitch input, velocity output, velocity input, middle C, and up. Now the interactive part of this is, what about changing other numbers sort of on the fly? This inlet over here takes velocity as a message. This one takes duration as a message. And you can change these numbers, which we call arguments, just by supplying a new number to it. So if I make another number box there, and another number box here, again, I'm just pressing I to get those number boxes. Here, that's the reminder. Helpful. Then I can say I want the velocity message to be 127, really loud. Or maybe I just want them to go a little quieter. Right? Is that working? Maybe I don't want them to last 500 milliseconds. Maybe I want them to last something very staccato, like 40 milliseconds. Yeah. So any of these things can be changed at any given time. There are other ways to do this too, so that you change values very frequently. For example, there's an object called message. Whoops. Message looks like that. And when you type out of it, it turns into this thing, which is a message. The message box inside of Max is so common that it also has its own key command called M. And you can type lots of messages, all doing different things. For example, if I wanted to make a message that I sent called 500, and I want to make another message called, I don't know, 40. I can make those two things. And then when my patch is locked, I can quickly just change that to that, and change that to that. Right? So it's a way of like shortcutting your way to get into those numbers. You can always still do this, you know, and change that, but you also have that shortcut there. You can do the same thing with velocity messages too. So suppose I wanted to have like maximum message there, and then like, I don't know, half of it there. Let's move some things out of the way. And so now, see how it works? You see how this could like totally spiral out of control and become very versatile very fast, right? Okay, cool. So one of the things that you should also be aware that you can do is, remember the button from before? Like, there's nothing stopping you from saying, when I press this button, I wanted to simultaneously trigger loud velocity and shorter duration. Right? So then you've got some other stuff happening here, and then you get this, and then it loads those two things. Cool? See how this is all going? Okay. You with me so far? Yes.
Yeah, I except for before you added the button,
Yeah.
over on the right, the time data, you have 40 and 500. So that's when they're both connected to the input below it.
Mm-hmm.
How does it read the 40 first, then the 500?
It actually doesn't read either of them until you click on them.
Oh, okay. So when you did those examples, I thought there was one where the sound changed over time. Did you? And I thought it was because of multiple values.
No, it actually didn't. No, it actually didn't change over time.
Okay.
Yeah,
Okay.
yeah. It's all event-based, all click-based. Yeah.
Okay.
Yep. Totally. And these values once again are in milliseconds too.
So the advantage of those, the upper row there,
Yes.
then is that you can type in a whole bunch of values and be ready to click on it at any point.
Absolutely.
Instead of entering, re-entering.
Exactly. Right. Exactly. That's the plan. Right. With that, let's talk about. Did you guys have a question or?
Mine looked different than yours, but I think, are you in 5 maybe, or?
I'm in 6. Yeah. Oh, you have curved patch cords?
I have curved patchwords and then one or two other little things you don't have.
Okay.
I figured it's fine.
Yeah, I think I might have turned mine off. Okay. It made me kind of keep the curved patch cords.
I have different output amounts of outputs for some of the things.
Oh, really?
Yeah.
Like an 8 node or? Shouldn't.
The numbers have. No, we're not seeing it.
Okay, all right, cool. Okay, that was going to freak me out, so I'm glad that's all good. All right.
Period.
Okay, cool. Yeah, very good. I'm just going to move some of this stuff over just a tad here. Now, the cool thing about Max is that I know it seems like we're learning a lot of objects right off the bat, and you're kind of learning this language, and you are. It's not an easy thing to learn it, but the more you do it, the better you get at it. For example, I should say that one of the things that's helpful is to let your sort of creative objective dictate what you want to do programmatically, okay? That you'll be a lot happier that way in my experience if you do that and then just sort of say, well, this is what I want to accomplish. How can this program help me do what I want to do, as opposed to what everybody does when they open up Pro Tools or anything live, which is, what does the program do? How do I fit into the program, right? Max is completely blank, you can do whatever you want with it. So my objective now, in the next 5 minutes, is to make something that randomly makes pitches. How about that? That's like something attainable, I think. So there happens to be an object called random inside Max, which will generate random numbers. It'll generate random numbers when you send it a bank. So I'm going to connect a number to its outlet to visualize what numbers it's outputting, and connect a button to its inlet. And when I click on this, it's sending 0 random numbers right now. Right? Now, if I give it an argument and tell it what range of random numbers to work with, or how many random numbers to do, then I'll have something. So if I say to output 128 random numbers, essentially 0 through 127, I'll log MIDI values. Then, when I click on this button, it's outputting random values 0 through 127. How cool, right? And of course, there's nothing precluding me from saying, I don't need that number box, I want to connect that one. So now that this one is not just outputting random numbers, it's outputting random pitches, right? Now, here is one of my favorite things about Max. If you get stuck and you're like, oh man, I have no idea how to use this random object right here, you can, with your patch unlocked, right-click it, or control-click it, and open the random help file. Okay, so it's the help file for each different object inside the program exists. So I'm going to click on that, and up pops this window where they show you a little bit about the random object, give you a little description about how it works and whatnot, and they even give you a working example of how the object works, okay? That's in the help file. Now, the help file is also a Max patch that you can unlock. And so you can, even if you like totally screw it up, you can copy stuff out of the help file and then just copy it into your patch, and then you got it. Like, how great is that? You can make whole programs just by stringing together help files. I don't know any other program that does that. It's fantastic. It's totally intuitive in terms of getting you moving at the ground level. Okay. So I close that. So now we're back to here. All right. So we've got this thing. It's cooking random numbers here. I'm just going to get rid of this whole thing for the moment. It's kind of cramped my style. So we've got this thing. Outputting random numbers, I like it. Except, you know, when I'm at the club generating my random numbers like this, you know, I like to be dancing around. I don't like to be tethered to a computer like that. So it'd be great if we had some sort of automatic random number thing cook in here. So in order to do that, I will use an object called Metro. Metro is like a metronome. You specify some value in milliseconds. I'll say like 500 milliseconds. So every 500 milliseconds, I want this thing to send out a bang. Use an object called, it turns on and off by using an object called toggle. Okay? The toggle is such a common object in Max that it too has its own key command, which is just T. You press the letter T, you'll get a toggle. Okay? And there it is. Toggle has two states, on or off. It's like a binary type of thing. So with the patch locked, if I click it, Metro is on, and every 500 milliseconds it's going to send out a pulse. If I click it again, the toggle's off, and it's not doing anything. Okay? So, you see what this is going. I don't need that. Right? And try and get it all on screen. of the 500 is that every 500 milliseconds, Metro is going to send out a pulse.
Okay. Oh, there's no.
Yes, yeah, exactly. It's also the most best dressed object inside of Max. It's Metro. Okay, so now, like any of these other objects too, you see these inlets over here, they do stuff. So this one says set metronome time interval. What does that mean? It means if you send a number there, just like down here we replaced this duration value and this velocity value with other numbers, you can do the same thing over here. So if I create another number box here, and I say I don't want it to output numbers every 500 milliseconds, I want it to output random numbers every 50 milliseconds. Then, every 209 milliseconds, right? Something like that. Now, there's some overlap happening here too, because it's still making MIDI notes every 500 milliseconds, so it's not true legato, right? It's this other thing. So how can I fix that? Well, that's really easy actually, because if I want to update this one to be the same as that, I'll just use the same number box. So now, when you change a number here, its duration will last this number, and it'll create a new number every this number. See how that worked? Yeah. So this is like random. Yeah. It's like 1970s Pulitzer Prize winning competition. Yeah, so. One second. How's that pencil? You need it. Everybody doing okay so far? Okay.
How do you do ready comment like that?
Oh, sure, absolutely. It's a new object called comment, where you press the letter C. So I'm going to make a comment called comment. It's like a dream within a dream. Yep. Okay, so that's that. Yeah, if the metro goes below like 20, it starts to really get insane. Now, at the same time, we're working with MIDI data, right? So you know that we can have separate MIDI channels to have multiple streams of data flowing simultaneously. In fact, you can have multiple instruments like this that all do different things. It becomes most apparent that you would want to do that when you differentiate the timbres between these different instruments. Timbres in MIDI are called programs. Okay, so there are 128 different MIDI programs that we can have in here. If you're using a sample library like Contact or Massive or whatever like that, then you can, it's sort of a different ball of wax, but it's the same idea. Okay, so in regular MIDI, the way to transmit data out to QuickTime to get a change in MIDI program is with an item called PGM out. Just like we had MIDI out and note out, now we're setting program out, PGM out. Okay? Like this. So by default, it's working on out. But if I change this, right. So I can make some more messages. I want like my presets. Right, something like that. Right, so you do those types of things. Now, Memorial Day is coming up, and I know Grandma's going to go in the house and she wants to see your great Max program here. She can totally vibe with this idea of turning the toggle on and off, because that's a good control. But she does not like the vibe of her, this idea that you have to click in here and type in a new number and like click and drag, that is not a good control. It's not happening. So it'd be great if there was some sort of UI object, a user interface object, that help her control sort of like an on-screen type thing. And I'm going to move this out of the way. And you can do that with a number of objects that are built right into Max, one of which is called Slider. Okay? Slider by default outputs numbers 0 through 127, depending on where this little like knob thing is here. So if I'm another one that's popular is an object called dial. Dial also outputs random dial also outputs numbers between 0 and 127. So why don't we do this? I'm going to use this instead of making it also go for a program change. I'm going to add a change velocity. So in other words, here's the object, right? I'll repeat it. Right, when I click, it does this thing. So at its maximum, it's 127. At its minimum, it's 0. So I can make that become the thing that replaces velocity of the main node. Right. So now I can start these processes, you know, and control them, but with actual on-screen controls. Okay? In a little bit, I'll talk about how you can actually map those things to hardware controls or whatever. I mean, but you see just immediately how accessible it can be to do those types of things. Even something as trivial as this little mini controller with the broken key, you know, like me pressing that value right there. Let's go back to that. Let's see what I have. I had this thing. Let me do this. I had node in, and this was just the velocity number right here. Right? So I really hit it, it's 127. So like there's nothing stopping me from saying I want that to control mapping is everything in this program. You map data values to whatever you want them to be. If there's numbers, you can do whatever. If you have baseball stats from Ozzie Smith circa 1986, you can plug them into Max and use those values to whatever you want. Props to me for the Ozzie Smith reference. I wish everyone had seen that coming lately. I mean, like that's something. No one remembers the classics. Let's even get a Darryl Strawberry reference before the end of the night. Okay? Okay. So, as musicians, we are, not always accustomed to talking in terms of time, in terms of milliseconds, I'm guessing, right? Maybe, I'm not, so maybe instead of using metro like this, we will use an object called tempo. Okay? Tempo takes a number of arguments, first of which is beats per minute, which of course you can change. Second one is a beat multiplier. If you want to quickly multiply or subdivide the beat, you can do so. Let's keep it at 1 for right now. So we'll do 120 beats per minute, no beat multiplier, and then some number here to be a division of the whole note. Okay, so if you do 4, it's in quarter notes. If you did 8, you'll be eighth notes. 2 would be half notes, 1 would be a whole note. So we'll just do quarter notes at 120 beats per minute. Now, that's the tough part. Just understanding what it does. The basic gist of it is that it works just like tempo. Here's my toggle, T, for toggle to turn the thing on. And there it is. That thing is beating quarter notes at 120. Fantastic, works for me. Again, you can look at all the inlets here for this object. This one says tempo in beats per minute, so I can set it so that this number box over here will be used to vary that. So if I said like 180 beats per minute, right? I can make some message boxes over here, one that says like 1, and that's going to replace the 4. So now it's going to be whole notes at 180. See how that works? I can say half notes. How else? Quarter notes again. Eighth notes. Really anything you want. Eighth notes. So I guess the thing that we're missing here, here's 8 notes at 180. Here's 8 notes at 120. There's quarters at 120. 16th notes. Not a lot of fun if it's not playing a note, so let's fix that. Metro, send the bang to random at 128. And that. Send it back. Is this working? Okay, so that's getting that thing cooking there. Any questions so far? Useful? Okay. Want to come forward? I'm going to take a quick second to just save this. Now, why have one of these when you can have 2? That works for me. So, doing that in Axe is really easy. I'm just going to copy it. Go here. Here's a copy. Ta-da! In order to set it so that I don't get these things confused, I'm going to set this one so that this one does note out on MIDI channel 2. And this one does program out on MIDI channel 2. And then I have this thing. Right? I can even have the same toggle control both of these things if I wanted. Right? So they both off. Now, there's also nothing stopping us from limiting the range of this, so it's not always doing the full MIDI spectrum. For example, if I wanted this one to just output like 1 octave's worth of notes, random 12, it's going to output pitch classes actually 0 to 11, right? So that would sound like this. Those are pretty low notes, even lower than dubstep. So one thing that probably want to do at that point is to raise them up a few octaves. And you can think about it the same way that you would explain this to a little kid. I know we think of the idea like, okay, obviously it's way too low. But I think about how you would explain it to a student or like a little kid if they were asking you, how come this is so low? Well, you need to raise it up a few octaves. Well, how do you do that in math? How would you do it in real life? If you're playing down here, notes are too low. Okay, shift everything up 12 half steps. Okay, go to 1 octave. Still too low, another 12. Still too low, another 12. So, how do we make sense out of that in math? You just would add, just like we did in the first thing. There's all this stuff. If you add 36 to some note, 48 to some note, you're adding 4 octaves, right? 12 times 4 is 48. So if you take this number here, disconnect, click on it, and delete it. At random pitch, display this. You add 48 to it, goes over there. And now, right, get the idea? Now it's all within 1 octave. How great is that? So, Schoenberg would kill with this patch that we have right here. Okay? And we spent months doing it, and then we did it in like an hour and a half. An hour. Great. Okay? And of course, if we're going to do that, there's nothing to preclude us from doing other types of things with this. Let's make a third. Why not? Copy everything? I did. You want to do like really split though, and you don't want to be just Control-C, Command-C, Command-V to paste up. You can hold the Option key, and you can like click and slide over like that, and whoa, it makes a copy, right? And then prepare to be impressed by, for people to impress with you. That's a really cool stuff. Okay. So I'm going to change this to MIDI channel 10. How about we make like a drum instrument too? How sick would that be? Program change doesn't really matter if something's MIDI channel 10 because it'll always come out sound like drums. Okay? So, okay. Well, I know for a fact that MIDI note 36 on drums is kick. Because I've done that before. And so here's MIDI 38, which I'm sure is going to be snare. You are probably sure as well. Awesome. Okay, so if I want to get it so that this thing alternates between kick and snare randomly, how do I do that? Any guesses?
Random 2.
Yeah, that sounds good. It'll give us another note in between there, but random 2. Allow for a total of 3 random numbers. Okay, so plus, let's see this, new number, so we can display it. So there it is, outputting 2 total random numbers, 0 and 1. Now if we set it to 3, you can get 0, 1, and 2 happening. I'll show you why you might want to do that in a second. So then if we add plus 36 to this thing, then when it receives a 0, it'll trigger pitch 36. When it receives a 1, it'll trigger pitch 37. When it receives a 2, it'll trigger pitch 38. So right? this thing here. And that. So now this thing. And while that's going on, I will just say that all of these patches I can give to you at the end too, if you want sort of copies of mine. I can certainly make that available to you. And I'll put my contact information up at the end, and you can email me if you have questions about that stuff too. All right, so the Amir kit that I asked you to install has a bunch of objects and shortcuts, little patches that I made that I think make doing these types of things a little bit easier. For example, there are a number of different controls that you might want to put in here to get this thing to play back. And there are a number of ways that you can filter this thing so that it plays diatonic music. So one of the easiest ways to do it is using the stuff that I provide. So if you go to the extras menu at the top, you'll see that there are two things now added there, one of which is called Amir. That stands for a project that I was involved with, that I started, called stands for the Electroacoustic Musically Interactive Room. The emphasis of the project was to create an interactive room for kids, particularly special needs kids, but also mainstream kids, to play music and compose music using different alternate controllers, whether it be video game controllers or sensors or whatever. That's kind of where that project started, and this was a development kit. This thing here was a development kit that I made that helps make doing that easier. Okay? So it has a number of different examples, all designed to get you making instruments quickly. Okay? So I'm going to quickly look at this thing, and then I'm going to get back to this patch underneath here, and we're going to make some sense out of it. Example 1 shows you MIDI basics. And what you have here are essentially two modules. One is this thing that has everything you would need to get MIDI input, and this thing down here which has everything you need to work with MIDI output. And what do I mean by MIDI? Everything you need. Well, over here it shows you all of the MIDI devices you have in your computer. It shows you this keyboard, which is going to sort of display what you might have coming into here. It has panic buttons in case you have step notes. It has different displays to show you more or less keys, depending on what you want to do. All those goods right there. Same thing with this MIDI output stuff. It has different types of program changes built in there, stuff to record MIDI, stuff to send MIDI on different channels, or to send it out to Contact or GarageBand or Logic or Finale or whatever. It's all in there in that first example. Done deal. Okay. Next, I have a bunch of other control interfaces that we will talk about in just a moment. I do want to get to this fourth one, MIDI filtering. Okay? The idea here is that this has the exact same patches that we looked at just a second ago. It's that MIDI input thing, that MIDI output thing, and then some other junk in the middle. But what is this? This is some other little patch that I made that filters non-diatonic notes to diatonic notes. In other words, I'm here playing close this patch for a moment so you can see. Okay, so CDE. Great. We are clearly in, this little keyboard. We are clearly in C major, right? So if I press F sharp, to the life of me, it just will not play that F sharp. Why? Not from C major, right? If I bypass that, it certainly will, but as long as it's on, it's not happening. You can plug like a Bach piece into this thing and it'll never do a secondary dominant again. It will never happen. That sucker can't modulate. It's great. But the point of the matter is that when you start working with interactive things like this, like the thing we made before, the problem is not that you can't get enough data. The problem is often, in my experience, that you have too much data and you want to restrict it to something that's usable, right? So in this case, we want to restrict it so that you have just a key or just some 7-note collection. So this little module does just that. It in itself is just another patch. If you were to right-click this thing and go down here where it says Object, click an Open Original Mirror Filtering Patch, you'll see that this thing is just some patch that I made that does stuff. It has some little object here that I made, some little hot sauce. I'll show you that stuff in a bit. Should I pose for that picture?
That's a good one.
True or false, that's going on my Facebook tonight. Yeah, okay, so what does that mean for us? Well, I'm going to copy this thing, and I'm going to open up this jammy over here, which we were just working on, and I'm going to paste this in. Piece of cake. So there's that. And try and keep this as organized as possible. Okay, so random generates pitches. Great. I want the pitches to be filtered in the key of C major. I can do that too. So that's all cooking here. I can get other modes too. You do C with E in flat 7. Ooh, Wood 4, melodic minor. That might be hot. Okay, so we'll just go with C major timing. So if I were to type in like 60, that's middle C. That's allowed through. The C is in the key of C. C sharp is a note right after that. That is not in the key of C. So 60 comes through again. 62 is allowed. Right? 63 is not. And it'll work just like that. So what does that mean for us? It means that this thing here, when this thing is cooking, questions about that? All right, good. So then it comes down to, well, what if I'm not entirely so happy with this idea of clicking on the screen like that? Like, because that's sometimes fun, but sometimes not always fun. Well, what other types of controls can I use? Great questions. There's an object called key, and the key object gets information based on what key you have currently held down on your computer keyboard. For example, there's something called ASCII. Our computer keyboards are ASCII keyboards. So each different key that you press is a different number associated with it. Get it? So you just tell Mac to do something special when it sees certain numbers. For example, there's a number called select. And select says whatever you specify as an argument for select, whether it be like 32 or hello or mom, 27, whatever these types of things are. When it receives that input, it sends out a bang. So down here it says bang if input matches 32. Okay? And then bang if input matches hello. I'm guessing that one of these keys will output the number hello. Okay? And then the last one is, like, this one is 27, I think. Yeah. And then the last one is just like, if the input doesn't match anything, just send that out. Okay? So like if I send the message mom to here, there it is, right? 32, hello, mom, 27, nothing. There's mom. If I press some keys on here, they don't match any of these things, so they all come out over here. But if I press 32, what key is 32? Space bar. I had that one memorized. You know what? Space bar is the biggest one. When you do a piece, set the only control that the performer has to do to the space bar, because it's probably the only one that they know where it is. Okay? And it's the one that they definitely won't miss. It's the biggest one there. Okay? So 2 keys to really know for starters. Spacebar and the escape key, that's 27. Okay? But for the point of what we're doing, there's nothing to stop us from saying select 32 when the spacebar is pressed. Let's turn this on. We could very well do something like this, where we have, I don't know, 49, 50, and 51. That's numbers 1, 2, and 3 on there. So I'll have it so that when 1 is pressed, it triggers that on. 2 is pressed, it turns that on. We also set it so that when 3 is pressed, switches that on. Start to build in your own controls to suit your performance now. Okay? So why don't we do this? Why don't we take like a 3-minute breather, and then we'll come back and we'll start talking about some synthesis stuff, like actual sound files and some things you can make some decent. Okay? Quickly walk you through a couple other things in this kit so you'll know, when you have some more time to look at home, what's in here. Second example shows you 4 basics. I built a library. If you go to the extras menu, there's also something here called the Modal Object Library. This is a library that I built that explores musical modes. So the first object is one called Modal Change. You type in a tonic and a mode, C sharp major, and it gives you the pitch classes for that mode. Okay? And it tells you it's mode 1 of the major scale. It uses the distances and half steps between the notes. So whole, half, whole, half for major scale. then you go to any of the diatonic modes, and it'll show you, okay, there's mode 7, harmonic major scale, or here's some melodic minor, here's like mode 4 melodic minor, C sharp, Lydian, or C Lydian flat 7. It gives you the pitch class for all these things, and you can type in just half steps and whole steps. And these, this is useful because then, based on that information, you can, just like we do, you can build up chords and harmony and whatnot. So other objects in this library include, well, number one, the Messiaen modes too, you got that, but also modes that show you how objects show you modal relationships. For example, if you're in the key of C major, what are all the related modes? Well, all of these modes right here share 6 of the 7 notes in common. So in other words, you're in C major, you shift up one note from the scale, half step, or or up or down a half step, and then what mode are you in? Well, if you shift up just C to C sharp, that's actually C sharp, Locrian, flat 4. So, which is mode 7 of melodic minor scale. Okay, well now here are all the related modes from that. Like you can get to any of these sharing. So a whole library of modes that you can get to, and that sort of thing. I was really big on music theory. Sort of nerdy, but just go with it, don't hate. Okay, so lots of other things in here. Triads, of course. Like, why just specify? Why would you want to specify like 60, 64, 67 every time you want to play C major chord? If you have that information there, with this you can just type in 2, 3 chord. Right, so like all that information is just there and like accessible to you. So lots of different things in that library, different things for analysis, chord analysis, scale analysis, all included. The sort of easy way to look at it, back to the Amir stuff, is this one, example number 2. This shows you, here's the C major scale, what chord tones do you want? I want root, 5th, and 9th. Everything's going to sound like Rush, or like the Police. Right? And then it's just the same guts that we had before. Here's the MIDI output stuff, right? You can go in here and you can change the chord voices. I mean, doublings of each chord tone you want. So, I think I adjusted a note. Right, so you can do anything in here that you want to change that. And I'm just clicking 1, 2, 3, 4, 5, 6, 7, 8 to change those chords. But in the next example, it shows you how you can use a regular keyboard to do that. Remember that key object we just used a second ago that showed you that it does this? Some wackout actually made a patch here that shows you like every key is all hooked up to a button. So like here's that, right? So every single thing that I'm pressing on lights up. You do capitals, it does that. And so each of these little blinking purple buttons here can be mapped to something, depending on what you want to be mapped to. I only mapped 8 of them, actually 9 of them. Here's what I mapped them to. Press the number 1, plays the 1 chord. 2 plays 2 chord. 3, 4, 5, 6, 7, 8. So like the next time somebody says to you, hey, can you play that Killer song or that my favorite Lady Gaga song or whatever, and you say yes, it's clearly just a 1, 5, 6, 4, right? Like forever. And then I had this big format that doesn't go off. But I mean, like in terms of performance interfaces, I've done a lot of things with Guitar Hero controllers, and that's all in here as well. Like remotes, color tracking, which we may have time to get to. If not, there's an easy module right in here for how to do that sort of thing. I'll show you too quickly. camera control. So using it to track some color of something. Let's see if it'll track this white, this sort of gray color. Let's see. Give me something brighter. I'm going to keep a laser with me here. That's something here. I think that the blue from this USB thing should do. Maybe? Right? So now we can form this one out with like a laser pointer, because that's like pretty easy to track that color there too. But look at it, in general, it's not a whole lot. It's this thing, which is tracking a color, and it just outputs a number. That number goes to this thing, which determines range. Like, all this stuff is documented. The point of the matter is that you don't have to reinvent the wheel with a lot of these things. You can just copy and paste and do what you want. So, like, the way that I have this kit set up is that if you want to copy, like this is tracking pitch, maybe you want to have two. Okay, fine. So now, here's the thing that gets it from the video camera. There's two of me. And then, maybe you have two laser pointers. Maybe, like, these things. Did I kill it? Like these things. So, like, that one tracks that. Maybe this one tracks my face. You know? I mean, it can be anything you want, really. And then map, it's just all about mapping, like we've been saying all, you know, just what you want to do. So that's that. So there are a lot of cool things in there, in that kit, target controllers and whatnot. I happen to be a bit of a fan of just the mouse and the keyboard, because they're built right into the computer, okay? And you don't have to bring extra stuff to the game. But if you have, like, the Ableton Live, or I should say the Akai controllers and all those buttons. There are so many controllers out there. In fact, if you have a mini keyboard, they all have knobs and buttons on them, and nobody does anything with them ever, right? They're just kind of there, and you just, wow, it's great. I paid an extra $200 for these buttons that I'll never use in my entire life. You can map those buttons to stuff to trigger different things, and it's totally doable inside of Macs. Just use like the Node In and the MIDI and stuff, and it'll show you. Okay, so that's that. Let me now walk you through some basic ideas behind like working with sine waves. Okay, so let's make a new patch. And I'm going to call this patch, we can find and save as, I'm going to call this audio basics. Okay. The basic gist of this is that MSP is a collection of objects that handle signal processing, as opposed to just the Max objects, which do more number-based things. They all integrate with each other nicely, and they play well, and it's just an extension of the language. Okay? So, one of the basic ideas here is that we work with something called a DAC. Okay? That stands for anyone? Analog converter. If you live in Europe, you would spell this like this, I think. Right? E? Analog? Yeah. Like that, right? Something? I'm not exactly sure exactly how that works. We Americans spell that way. Yeah. Analog. So this is always called a DAC, as opposed to this other one, which does the opposite. ADC tells you, this analog to digital converter. This one's never pronounced ADIC. This one's always pronounced analog to digital converter. What does it mean, in case you don't know? It means that the microphone is converting our analog world, the world we hear with our ears, into numbers, so our computer can do something with it. And then when we want to hear it again, the digital to analog converter, it's at the end of the line. Just like we use no doubt is like the end of the line. The DAC is the thing that lets us hear it again. It turns that digital stuff into a sound that we hear. Okay? Inside of Max, we have not only these two objects, but we have sort of ones that are easy to work with. The way you turn these things on is you send a toggle to them, and then sound processing is working, like that. But you can also use an object called EZDAC. So there's letters EZ in front of DAC. Closed. And up, go away. For a max file. Same thing with this. EZ, ABC. You get these things here. This is EZDAC. Now, they all have a tilde at the end. Okay, that little squiggly line. Because it's like a wave. Get it? Right? It's clever? Okay. You understand. So, if I use an object here called meter tilde, this can actually be like a meter for measuring if there's sound coming out from my ADC. Okay? The first outlet is audio channel 1. The microphone built on my MacBook is a stereo microphone. And so channel 1 is there. I'll also send channel 2 here. And if I lock my patch and turn this thing on, then you can actually see that while I'm speaking, stuff's going through there. Right? Right? Now, if I were to connect this straight to here, everything I'm saying would be coming out of the speakers while I'm saying it, and it would probably make feedback. But it would be working that way too. Okay? It's important to think about this thing sort of safety in mind. If you're going to work with this stuff, it's really easy to deafen yourself. So just be careful that you don't do that, especially if we're with headphones. I know we always say that, but here I am saying it again. Okay? There's an object called gain tilde, which turns out to be like a gain knob, just like on a mixer. It'll control the amount of signal you're allowed to go through. Gain tilde. And again, all of these objects have a tilde at the end of them. Okay? So what I'm going to do is disconnect this. Just by clicking on deleting them. My microphone sources will go to this gain, and the output of the gain will go to my DAC, okay? And also connect to the meter. Make sure stuff's still working. Sound, lots of sound, no sound. Lots of sound, no sound. Right? See how that works?
At this point, you put it in the left and right channels. Something about that at all?
It's not. Well, here's what's going down. It's a great question. Here's the DAC. Here's EZDAC. EZDAC, by default, the thing that makes it easy is that it's just pumping out stereo. It's not configured to allow you to do a multi-channel type of thing. If you want to do that, you would use something like DAC tilde 1, 2, 3, 4, 5, and assuming that your sound card can pump out 5 different channels, if you double click it, you can actually look at what sound card you have connected here. But that would be that. And so this would essentially be channel 1, channel 2, channel 3, channel 4, channel 5. You can set any audio sources there. With EZDAC, channel 1 left, channel 2 right. This is technically a mono source right here, and I have it pumping to 1. If I wanted to go just to the left channel, now it's doing that. If I wanted to have a second one of these, go to the right channel, I can do that too. So right now, this is in stereo.
How do I turn it on so that it's actually monitoring the microphone?
Once you have the thing in place, with the patch lock, just click it. You see it turns like a light blue?
Yeah.
Did it do it for you?
Nope. Oh, yes, now it did.
There we go.
Thanks.
Well, yeah, no problem. One of the things that is sort of a pet peeve of mine is that with with the Easy DAC and the Easy ADC, the color is like this light blue. So you can't even really tell if it's on or off. It's really not a whole lot. So what I tend to do is this. If you right click these objects, you can go to the inspector. Every object has certain properties you can change, colors and whatnot. And for number type things, you can specify different ranges of numbers and whatnot. So for this, I tend to always change the foreground color to be red. It's just easier that way to see, like, is it on? It's on, right? Same thing with this. So that's just right-clicking it and going to the inspector. Boom. Done dealio. So, there we have it. Now there's sound coming through. Light is good. All's right. And again, you can resize all these things too. You can spend like your whole life doing user interface sort of things like this. And people who use your stuff will thank you. Okay. Maybe. No, they won't. They'll complain like all hell if it doesn't look good. All right, I'm going to close this for a second. I do want to show you one of an existing project that I have. Sort of one here. That I did a while ago called Nil. Here's the score. It's a guitar piece, guitar and stuff, and you see that it has just notated new guitaristic things. And the idea behind this piece is that the computer, this Mac patch here, is going to do certain stuff to the guitar signal live in time while stuff is cooking. So I'm going to have it set to do sort of like a demo. This is just a max patch. It's going to, if I had a guitar here, it would be loading, it would record what I'm going to do while it's going on, but it's going to play like a wave file of guitar. But it's still going to do all the processing live. And so under the hood is this patch here, which does all sorts of stuff. But you can see it's just, it might seem a little complicated, but it's just all the sorts of the same things that we've been talking about. It does some numbers here. You know, it just throws things around here, some keys over here that start the thing. And if you plan this stuff right, and nobody ever has to see kind of like what your guts look like. So the performer then just get up on stage and they press the space bar and this counts them in, and then this would be the guitar player playing. Now what's happening right now is that those first four notes, the first three notes, the bing, 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 it recorded what it played into a little buffer. And it's going to manipulate that buffer all throughout the rest of the piece. I'll show you in a second how to do buffer related things. But you'll see this whole measure counting thing. What's going to happen is the same select module that we had before, select key, whenever it sees a certain measure and beat, it's going to trigger different events to happen. And those events are, like this thing just jumped up. Right? You'll see these numbers start to code over here in a second. Right, see the measure number there? Actually, watch these faders come up. very simple things that happen, but just sort of structure. It's just, this happens at this time, select. So back to what we were doing here with this basic audio stuff. How do you work with a sine wave? Seems like a fair question. And I'll show you how. I'm going to move this stuff sort of out of the way. Actually, I'll make a new patch altogether. New. And another easy deck. And gain, tilde. Okay, stereo. Red. There's an object called cycle tilde. The idea behind cycle tilde is that it takes some number. You can use an integer like this. You're probably better off using a floatum object. Floating point number, or just press the letter F, get a floating point number, so you can get more exact. Okay? So we'll use a floating point number here. It's really simple. If you, thing is on, if you want to have 1 cycle per second, this gain thing right here, you probably don't want to let it go above, much above 120 or so, okay? It starts to get distorted a little bit. Okay? So great, we got a sine wave cooking. I'd like to see that sine wave. Erase your sine wave. So there's an object called scope tilde. It does just that. So displays that sine wave cooking in here. And depending on how fast your graphics processor is on your computer, you may want to increase some of the properties for scope. Let's do that. With your patch unlocked, right-click on scope and go to inspector. And you can change the refresh rate, they call it cal count, from 256 to 20. Now this thing is doing this, so now like, right, if I really ping the thing, yeah, you can see it like that.
Did you make a faster refresh rate or a slower refresh rate when you did that?
Faster refresh rate.
Oh, so it's
It's 20 milliseconds.
Okay.
Yeah. Cool. And why have one when you can have two? So copy. Ta-da. You actually only need one DAP. You can share. Right? So this will also go left and right. Like that. And then this one will do, see that one's 65, we'll do 65. Like that. This can make like binaural beating. Let's see. Right, see where this is going? Yeah.
And that number you're putting in corresponds to hertz.
Yes.
Per cycle per second.
Yep. Right. So there's 440. Here's like 1 octave above. Right? And then everything in between. So you can make like your very precise Harry Potter instruments, just right here. Can do all these types of things. Can we get that reference?
Yeah.
Okay, cool. So maybe someone like throw up a sign, a Harry Potter sign. Okay, so, all right, so why stop there? Why don't we do this? Oh, let's show sort of like, I'll lower it so it doesn't deafen you. But what if we do like a combination scope of both of them? Wow, I was totally sick. That's great, because they're combining here, so that'll go there, and that'll go there. So now we've got a complex wave, so there's that. Pretty cool. And of course you can stretch these things out. You know, make them whatever you want. If you want to be like really like slicko, you can change the colors of this stuff. So that's cool. Kind of. Yeah, right? So it does that. If you're okay with like pinning one, you know, like that, you can see like what it does, how it affects in time. Is that painful? And of course, there are different types of waves besides cycle. You know, so you can get into like sawtooth waves and these types of things. You know, so all right there for you. Let me just save this quickly, and then I'll call this sine wave fun. I'll show you an app that I did in Max. This is just a series of Max patches. I can give this to you. In fact, if you go to that website again, engineer.net, you can download this. It's called Audio Utilities. They're just a bunch of Max patches. I use this to teach with. This is exactly what I'm talking about in terms of like Max and its flexibility. I was kind of tired of explaining the same sine waves talk to students, drawing the wave and a little bit, and so I made an interactive thing. So, so there. So there's the sine wave. This is exactly what we just did. This one happens to also work with keyboard. If it was plugged in, I guess it. Oh, wait. Right? So there's A. There's the A and below it. Great, perfect, done deal. Next little patch. You can do like a hearing test the same way, right? It's very easy. 8 kilohertz tone. How about like 10 kilohertz tone? We don't actually have to do this because it's going to get depressing for us, so I'll just skip to the next thing. I played in front of a Marshall stack for way too many years. All my mixes come out sounding a little crispy. I'm not sure exactly what that is. Couldn't be me. So here, this was like a simple harmonic series thing. Let's think of the concept and then think about how you might want to build that inside of Max. If you know what the harmonic series is, but if you're not, here's basically what it is. You start off with some frequency. It's your fundamental frequency. What you want it to be, maybe like A440. So like you give this letter name to a certain cycles per second, 440. And then the first overtone above that, essentially the second harmonic, is twice the fundamental. So 440 times 2 is, making this 2 math. What a jerk. It's 880, right, exactly. And so there's fundamental frequency times 2 times 3. And I'm just pressing the number keys now to bring these sine waves in. But essentially, it's really easy if you think about it. And you probably even envision how you would do it inside of Max. You had that thing that we had before with cycles per second, right? And then a gain times 2, and another one, times 3, and another one, times 4, and another one. But the point is, you get like this incredibly useful like thing out of the deal, right? And so when I want to talk about the harmonic series in timbre, I need only talk about that sort of thing. And all the overtones are right there. And then you talk about how you take the partials out. So there's our timbre, but then you don't notice it until you start taking them all out. So yeah. So just a whole bunch of audio utilities here. And again, nothing really to like write home about in terms of like, wow, that's the greatest program I've ever done. But it's so useful, right? I mean, like if you want to just work on these things. And in terms of what we do with composing, it can totally be the basis of something else. This would just combine sine waves. So it's basically what we were doing just now. I'm going to close out of that for the moment. And you can always get back to that later if you would like to. Okay. So back to sine wave fun, I believe I call this. Yeah, making a harmonic series out of this would be a piece of cake. You start off with fundamental frequency. Okay. And then, so that's there. Fundamental frequency we are deciding right now will be 440. Great. New object, star, meaning asterisk. I'll zoom in so you can see. Asterisk 2 dot, I'm putting the dots so it knows we're working with floating point values so it doesn't just like lop it off. And piece of cake. So now when this one changes, that one changes. So here's 440. And there's that. Cool. If you wanted to have a third one, I'm just going to move this stuff out of the way. You can see. This would be times 3 dot. Connected to easy that. Raise it up a little bit. 440. Right? And you're just building essentially the timbre like that. Now, the more precise you want to get with how many different partials you put in there, it's your own religious condition. Okay?
And sorry, I assume you can also move each of the floating numbers independently, right? Since they come after the multiplier.
Yep. Yeah, you can do whatever. Yeah. In fact, you can even have this thing set with if you decide to do node in. There's an object running out of space. There's an object called MTOF, which converts MIDI notes to frequencies. It's just like a table, you know? So like MIDI note 69 is the A above middle C, that's MIDI, that's frequency 440 in equal temperament. So, like if I play that'd be how that goes. Cool? Can we move forward? Still got some energy? Okay. It's like a runaway train when you start doing this stuff. Because there's so many possibilities of what you can do. Let me show you, actually let me show you this one. This one's kind of fun. This is sort of an advanced example of it. But you might dig it. This is a piece that I did a while ago. It combines a bit of a visual component to it too. I'm not going to really explain entirely what it is, assuming I can find it. But in short, what it does is it records something into a tiny little buffer. can see that it's picking up microphone input right from there. And then this is like the timeline. Okay? So just like GarageBand or Pro Tools or Logic that reads through and plays, right? There's no audio in there right now. When I press spacebar, it'll start recording what I'm doing, and it'll stick it in there, and then it'll keep reading through it. The program will do certain processing on it and do all these types of ways of manipulating it. It actually takes an FFT of it, which is a little bit advanced for what we're doing right now, but there's plenty of documentation out there. Okay? And I've had a look on it too, so if you want to see that. So I'm going to press the spacebar now, and hello there. Okay, so now it made this 2D picture of my voice. And the composition is that it's bringing in, it's turning this 2D thing into a 3D thing. Okay? And now the red timeline is set to speed up and slow down and go forward and backward based on what I want it to do. So none of this is random. I actually willed it to be this way. Now the second is going to do these like Photoshop type filters on the image. When it does that, since it's reading back from the image, it's going to change the way that it sounds. There it is. Right, so you get the idea of like kind of how that all works, right? And so essentially, the program itself has the composition built into it, okay? So even if you came up here and, you know, shout out the F word or whatever, it would still do the same keys except with your camera. So it would sound different, but it would still do the same calculations and operations in there, okay? And that was all based on some signal processing stuff. It's a little bit advanced, but there's an example in the Max documentation that does basically that. And my piece is sort of an invitation on that too. So you can work with those types of things. I did make a thinly veiled reference to this thing before. This is a book that I wrote. It's published by Oxford, and Max NSP Jitter for Music. And it's basically like a handhold type of book for getting you, taking you through projects that might be interesting to you in terms of developing chordal instruments, instruments that play chords or melody, or doing some sort of harmonic analysis or chord analysis or something like that. It's like this, except kind of spread out a little bit, and plenty of examples. Okay, there's lots of different things in there. Useful for research, composition, performance, and other stuff. Available in ebook as well. I don't know. It's you can get it on Amazon. I downloaded it. I hate that stuff, but so the hard copy is good. Okay. And again, it's published by Oxford University Press. So you can go to Amazon and you get that. Okay. Okay. So that's that. We'll look at. Running out of energy here, guys. Maybe we'll look at just one more thing and then we'll call it a night. How's that sound? Okay. All right. Inside of Max, there are ways to play back sound files as well. So here's one called Easy. play means sound file play. So you can send the message open, and then go find the sound file, play. I happen to have one right here on my desktop, which will play. Now, I opened up that file, and if I send it the message 1, it will begin playing. If I send it the message 0, it will stop playing. All of these types of commands, once again, you can get information on if you look at the help file for this object. So there's sfplay, and there's a whole lot of information about what it can do. More examples about how you might want to implement this into your patch, and also related objects too, that are like that. Okay, so consult those things frequently. You can, Max has tutorials built right into it. If you go to the help file, help over here, it'll show you Max tutorials, MSP tutorials, Joe tutorials. They're good. They're not so good at figuring out what it is that you want to do, so maybe it's not the most helpful thing. It tends to be very broad, because they don't want to limit it to, do you want to do synthesis? Do you want to do MIDI realizations? Do you want to do analysis? Do you want to do video stuff? Do you want to do just math things, signal processing, harmonic analysis, all these types of things. So it's a little bit abstract in that regard. But you can certainly work through them and find out the basic working knowledge of these things. So I loaded up that sound file. Now I press the number 1. It'll play that back at me. That happens to be my sound file, which is the Chris Crocker, Leave Britney Alone YouTube. Leave her alone. Clip. Okay, and so the point is, leave her alone. Leave her alone. Right, see how these things work. Now, there's nothing stopping me from creating multiple ones of these for different things, right? So here's that, that, and I will open this, and I will get that clip, and I press this.
Double rainbow all the way across the sky.
More YouTube type clips.
Double rainbow all the way across. Double rainbow all the way across. Double rainbow all the way across. Double rainbow all the way across the sky.
So if you happen to know the names of specific files that are on your computer, you can get those things to all loop too. For example, here's one that I know is already inside of this folder called Jongli, IAIF, and I can send it a message like this, loop 1, which means that any files that are going to come in, I want them to loop. That get cut off a little bit. There we go. So loop this thing, and here's open Jongli, and then
double rainbow, double rainbow, double rainbow, double rainbow, double rainbow, all the
so you see how these things work too. I mean, it just spirals out of control, and it comes down. So here's like sound file right here. Okay.
Sorry, what does the 1 mean after the loop 1?
Sure, it means that this object here has a looping mode.
Okay.
And a loop 1, a 1 would mean it turns it on, as opposed to like a loop 0 would mean like turns it off.
Are those the only 2 that it takes?
No way. It takes lots of different things. In fact, like I was saying, if you look at the help file for this object, you can look and see like it takes pause.
Oh, sorry, I meant in terms of the loop, like are the options 0 and 1?
Oh yeah. It's the loop function is either on or is off.
Oh, okay. Oh, I see, okay.
Yeah. So yeah, that 0, 1 thing is, you'll see that live. That's sort of like binary thing. Either 1 for on or 0 for off.
What if you wanted to take those 1s and 0s and hook them up to an external panel or something? What would you add?
Totally. So you can say something like this. Note, well, I'll use what I had here, but note in and I'll say, right, so this gets some note from my keyboard, presumably. So, if I want to say select 48, or select 49, when it receives MIDI pitch 48, it's going to send a bang. So, yeah, right? And then here's 49 something. Right? So, I can set this to be like loop 1. Oops, bro. Trying to make this neat. These trackpads, man, they're not easy to work with. How's that? That sound old? I think so. You young kids in your trackpad. Alright, so right now it's looping forever, and then if I press this, that, it's going to loop, and then I click that, and then it's not going to loop anymore. Yep. And again, and this is like probably the worst controller because you can't really step on this, but actually, you know what I think is the best controller? Ready? Here we go. This is the secret. It took me all my life and a PhD to figure this out. Logid is a company that makes a product called UMI3. Okay, it's 3 buttons and a USB cable. That's it. That's all it is. And to me, this is like the most versatile and easy to set up thing. Because this could be anything. This could be patch up, patch down, this could be on-off switches. Just stuff like that, just buttons are great. Another product that's really, that people dig, and first of all, this is really cheap. Another one, I think it's like $30. I mean, I use this thing so much, it's ridiculous, this stupid little device, because there isn't stuff out there that is just simple and compact like that. I love it, and I have 3 of them. There's another one called, I mean, you can get something crazy like the MP117, like the Taurus pedals, the Studio Logic ones. These things, I have these. Like they're great, don't get me wrong, but big, funky, really people tend to like this one too. I have this DFCB 1010 made by Behringer. And the point of them is that they're just pedals. They just do stuff, okay? And so that when those numbers come in, you say, okay, that's the number. Select that number, do this event that I like, you know, and then another number turns it on. You know? And that can be anything that you want. You can use a Nintendo Power Glove, or you know, a Guitar Hero controller, or a Wiimote, or a laser, or information from a web page. This is a whole app that I did. I'm going to close this. But this was my dissertation, essentially. I did this study, it's sort of involved, but the basic run of the app is that it's this study that lets you use the number keys 1 through 8 to play you know, chord functions in some key, and it's showing you there what key, what chord you're playing, where that is. And then if you are, these are actually just web pages. So when you go to a different web page inside of this program, like if you load up Glycerine by Bush, it knows, like, set this thing into the key of F, right? It automatically did that. It gets you set with like the right tempo and like loads up the right sound. Play along with the MP3. I bet you didn't think you would be having this. this happen right here. Yeah, exactly. So I mean, so it's like all there. I mean, this was entirely made inside of Max. So if you were like questioning, like, hey, I'd like to really like get caught up on like what progression is this? Like there, it plays the audio clip there, and then like you can like try out different things. This is going to be on my key. And you're like, oh, it was a 6415. Oh, how great, you know? The first inversion, you know? There you go. Yeah, so you get all those things going on. And this entire thing is Max. This is all done through Max. And if you sink the time into it, you can do really useful things for you. You know, when I first started using Max, I gave it up after like the first semester I did it. So why would anyone want to do this? It's so stupid. You know, like I just didn't do it. And then I started realizing when I was doing composition lessons, like I was saying the same things over and over again. People and students were just not getting it. And as much as I love my little scratch drawings on the sheet of paper with this circle refers to that, it wasn't happening. It wasn't happening nearly as well as I could do when I started doing stuff with Max. Started codifying scales and saying, okay, here is the difference between them. Look, they share this many notes in common. Look at how they could be related here. Look at how you can see the chords visually. Yeah, it makes so much sense. And so for me, when I started using Max to do what I wanted to do with it, it was like no holds barred. It was like the greatest thing ever. And as I've been doing ever since. And you can find out whatever your compositional or performance goals are. There's no other program like Max that will let you do that. Okay? Yeah.
Two quick questions.
Sure.
If you could go back to that patch that you had open, or you know when you had the 3 sliders, and they were doing the sound files.
Oh, okay.
If you deleted it, it's okay. You could just
Okay. Yeah.
or if you could just answer it in a broad capacity instead of triggering it with buttons or with an external controller. How could you set it up? A, to listen for a certain frequency to trigger a sound file, and then to listen for a certain frequency in time. And you know, like there's a window of time where you can listen for a certain frequency.
Right.
Once something is going.
Sure. Great questions. Okay. In terms of doing analysis like that, there is an FFT Silva object, okay, that will do that for you. Okay. Those things tend to be a little bit involved, but if you're cool for doing the math on it, you can do it. The forums are incredibly helpful, and they've got all sorts of tutorials to do it. So that would be the first part of it. Now, you should know this too. The Max user database has some really smart guys there. If you go to like the Cycling 74 forums, look at these. I mean, these people are so helpful. I don't know, but if you go to the forums over here, you can talk to people about frequency analysis, and then you can read a whole bunch of things where people are talking about need help with frequency analysis using blah blah blah, and you can read. And people post patches and they show little demos. Like here's a tutorial using FFT that will show you a lot of different things. Now you should also know this. There are external objects that you can get that are not bundled with the Max library that you can put in here. Just like my in-year stuff was in my mobile object library, that you can get that type of stuff too. So if you search, here's an object website called maxobjects.com. If you search FFT, you can see all of these other things that are more like narrow in their scope of what they might want to do. So you can find the right one there too. They do have a pitch tracking one built in called F0, which does basic pitch tracking. If you are saying something, it thinks I'm somewhere around that pitch, right there. I think it's trying to play back a pitch. close. If you go to the extras and the near stuff, there's not, I have two examples of pitch tracking. I have the one using F0, and then I have another one, where is it? Oh yeah, audio to MIDI using an external object. Sorry. Doesn't be a pretty looking right now. But okay. Well, there's that. But there are ways to do that for sure. Pitch to MIDI, if that's the technique you're talking about. Okay. And I forgot what your second question was.
Yeah, it's about creating a window, giving a window of time. If you use
Oh, sure.
tracks to track your entire
Absolutely.
piece.
Yeah. So.
Score following is what you want to do.
Oh, okay.
What is that?
You want to do score following.
Oh yeah, for sure. Yeah. So I mean, there are a number of ways you can do that. In Max, there are so many different ways to do stuff. So you can set something like this, like a counter. Or else I would say this one, clocker. So we're gonna add. Thing turns on. Right. So like there's some time that's happening there, and then you can say like select at a certain time, do that. Now there's also a more global way to do that with something called transport. Transport is like a regular transport. It does bars and beats and all that stuff, and you can set in your time points. So like at, I don't know, 15.3.0, like send a bang. And did I format that properly? I don't think so. Okay. Oh, I did, yeah, okay. So it'll do like that sort of thing. And then this would be like this. You just had easy ABC tilde before. Right, meter. Like that. And here's gain tilde. Alright. So right? So there's sound coming through here, and then now there's not, and then now there is, right? So at time point 19, do that, and then at time point 20, beat 2, turn it off again. Okay. It was already on, now it's off. Good one? Other questions? Yeah.
I have a low power, I have an old G4,
Yeah.
and I was thinking about I was going to get Ableton and with,
Max for
the
live.
Max for live.
Yeah.
So I have two questions. And first of all, how do you deal with, limited processor speed? And second, what do you think about Max for live as opposed to
Yeah.
Max?
Sure. First one, doing this stuff is actually really okay. Hang on, let me save this thing for you. Got it? Desktop, sound, cutter, offer. How's that descriptive? Yeah. These files are actually only, this one is 8 kilobytes. They're actually only text files that just reference a bunch of different objects inside of there. The thing that's CPU intensive most CPU tests is when you start doing lots of audio processing, just like anything else. So as long as Max will install on your computer, I think with the G4, I think they'll still let it install.
It's a 1.63.
It might be okay. It might be all right. If you're using it for real-time stuff, then I'm thinking you should definitely go to Max earlier in the day to make sure it's got the blessing before you do that. I think that video processing for sure is definitely not going to happen on that sort of thing. But Max is rock solid. I mean, I use it all the time, and as long as you don't mess up while you're programming, and you'll know what you do, then it'll become apparent what to do. In terms of Max for Live, I use Max for Live every single week. It's great. Here's the added advantage. I just showed you the transport inside of there. With Max for Live and Ableton Live, you have the benefit of an entire DAW inside of Max. Okay? So here's the one caveat. When I send out a piece, like I showed you Nil, the guitar piece for the score, when I send this out to somebody to play it, and what I'm sending them is the score and the program. Bundled in the zip file, boom, done deal. You need nothing else on your computer, Mac or PC, done. Start to finish, you need nothing else. It's the quickest setup time. People tend to like that aspect of it more than where's your Ableton Live patch, do I have the right assets installed, and what can I do there. So if I'm doing stuff, like when I play out with my band, I'll show you what my Ableton Live rig looks like. And there's tons of Max for Live stuff in it. But it's just me. Nobody's going to be buying that. Nobody's going to be performing that. It's just my stuff. It can be as sloppy programming-wise or ugly user interface as I want. When I am sending out something that's going to be consumed by more people, I tend to do it exclusively in Max. Okay? The added benefit is just time. You don't have to. You can save time by not having to program SF Play to play back sound files. You just kind of have it set there and loop. So there are some added things there too. If I was not doing the type of performance in my band that I'm doing now, where when I perform out, I bring my MacBook and my brother plays on an electric drum kit, so we pump MIDI in. I play my guitar through the guitar rig. It's a plug-in. So my guitar goes right into my Motu. My voice goes right into there. We have sequence loops that are in there too. Our bass player goes right into there. Our other singer goes right in there. Our keyboard player goes right in there. So it is literally putting all of your eggs in one digital basket. There's no room for error if it goes wrong. So we keep a backup. But here's essentially the session. And it's set as it is. We do not look at Ableton Live. Ableton Live. There are some built-in things, like this is their looper. This is my guitar amp over here. In a second, it's set to open it up, and there it is, so that I can make sure that my settings are good and all that stuff, and then I have a foot controller set to close it when I'm done. I had it set to change all the patches and all that stuff. This is something that changes, these are all automated, set the pedals and whatnot. But it sets the key of my loops and stuff like that. So if I was playing back this pattern, it's in D major, it's going to play along that line. But I can also set the playback in E major. So I have all this stuff automated in real time. I use that little Logi pedal to turn my vocal effects on or off if I'm talking to the crowd. And this in itself, if I were to open this up, let's stop this one. If I were to open this thing up, it is just Max patch. Which is again. So it lets you write a Max patch right inside of Adobe. Second in the bottom. But other than that, it's not like that's the added benefit that you have. You're essentially programming right in there. But everything you know in Max will work just the same in here. Okay, Noting will, instead of having to use the MIDI sounds that we used before, you can use any of the sample libraries inside of Live. So that's like an added benefit too. Okay? Does that answer that? That'll pop up eventually.
Well, I was just going to add that Ableton says that they need a higher processor speed. That's how they got back to me.
Okay.
And then the thing with Max is that the Max thing was like, well, you can use it in Live, but you have to be using Live 8. Live 8 is what you're supposed to use if you're using Max MSP. Is that
Right.
true? I mean, is
Well,
that-
Live 8 is the most current version.
Yeah, and that's probably the most CPU heavy, I think, of all of them.
Oh, you're saying as opposed to like Live 7 or something like that?
Yeah, I mean, I'm just wondering if I.
Why don't you just get a new computer?
Oh, sure, that's the obvious
Yeah.
solution. Is
Yeah.
money back.
Yeah, there's no way, I don't think that you can run Max for Live in any of the earlier versions. It's not like a plugin like a VST
Right.
or anything like that. There's actually extensions built into the Ableton Live. I'm almost certain that it will not allow you, that are just not there in previous versions.
Okay.
So that's that.
Right.
Yeah. Yeah, okay, other questions? Okay, well, look, let me throw up my contact info. I don't work for Cycling Saving Board, just so you know. Just for that. If you have questions about where to find resources or something like that, to me, you can email me. Pretty helpful, something like that. Of course, the Cycling 74 forums are even more helpful than I could ever be, so you should probably check them first. Do some reading on the forums before you do any posting on there. That forum does not really suffer fools lightly. Okay, so yeah. So that's that, guys. Thanks a lot for having me here. It was really great to be here, and yeah.